Hi. The heliocentric model of Copernicus was verified by Galileo's observations of the phases of Venus and the moons of Jupiter in the early 1600s. And in that same century, Isaac Newton proposed that gravity acted between every pair of objects in the universe, something called the universal law of gravitation. Well, after that, in the 1700s, a new planet was discovered, Uranus, and Uranus was found by William Herschel with a fairly small telescope, a replica you can see here. And Uranus was found just because William Herschel was a diligent observer of the sky and was able to see something. Here we see a photograph of Uranus taken with a small telescope similar to the one that William Herschel discovered it with. And so he found that it moved over a period of nights, did not stay in the same position, followed the same kind of behavior as the other planets, which were the visible planets. So Uranus was the first planet to be discovered using a telescope. Well, ultimately that had a big effect on understanding gravity. And to look at that, every pair of objects in the universe has a force between them that is equal and opposite. Both there's a force between object 1 and object 2, and a force of object 2 on object 1. The distance between them is r in this case. It's between the centers of the two objects. The mass of object 1, m1, and the mass of object 2 are multiplied, and you divide by the distance between the centers squared. And the constant g is the universal constant of gravitation, which essentially gives us the strength of gravity between any pair of objects. And so, why is Uranus important for this? Well, the planets were beginning to become a little bit complicated in the solar system. First of all, in 1801, the object Ceres, which is between the orbit of Mars and Jupiter, was discovered, and it's the first and largest asteroid, and we now know it as a dwarf planet. Some other minor planets were discovered very soon after: Pallas, Juno, and Vesta. All of these were between the orbits of Mars and Jupiter, and many new planets, these minor planets, were discovered, and ultimately the question kind of was a concern about, were all of these planets that are in between Mars and Jupiter, they weren't really the same as the other planets. And then a very interesting thing happened, because a new planet was predicted based on deviations of the predicted and observed position of Uranus. So from about 1820, predictions of the planet Uranus in its orbit were not consistent with the actual observed position when people looked at it through the telescope and found where it was. And so people thought that it was possible that another planet existed, causing another force of gravity pulling on Uranus from a planet further out that could cause those deviations. And in fact, that's what was the cause of the deviations, and Neptune was discovered in 1846. by Urbain Leverrier was making predictions and about the effect, and being able to try to estimate the position of the proposed planet Uranus. He used the idea of something called Bode's law, which is an estimate of the spacing between planets, and that, sure enough, along with the deviations in Uranus's orbit, allowed a prediction for the location of a new planet. And he informed the observer Johann Galilei, and he observed it within 1 degree of that position, found the object on September 23rd, 1846, that we now know of as Neptune. And Jonathan Couch is also credited for predicting the location of the planet from Newton's laws of gravity. He was not able to get an observer to locate it, but he was making similar predictions to Leverrier. So by 1851, just a few years after Neptune was discovered, 15 of the minor planets had been also discovered. So we now had the 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, but also 15 of these minor planets had now been discovered. And all of those were between the orbits of Mars and Jupiter. And so it was becoming apparent there was an asteroid belt, a belt of objects, a belt of minor planets in the region between Mars and Jupiter. By 1903, 500 of these objects have been discovered. And then in 1930, Pluto was discovered. So the prediction was made by Percival Lowell of the Lowell Observatory in Arizona that another planet could exist beyond Neptune, and Clyde Tombaugh working at that observatory discovered Pluto. And his method is by taking images of different regions of the sky, one at one time and then another at some other time later, probably a few weeks. He then used a machine called a blink comparator, which is shown here. Clyde Tombaugh is looking through it here. Here's the actual picture of it in a museum. And what happens is, as you switch back and forth a lever, a mirror switches between the images, and if the object is moving, then you see it move in a position from one night to another night. And this is an indication that it could be a planet, or a minor planet, or a planet, depending upon how bright it is, how fast it's going, and how big it is. So Pluto was discovered in 1930, and it was considered to be a planet straight away from the beginning because it was well beyond Neptune, and it was not in the asteroid belt, although it was small. Another planet called Eris was discovered in 2005, and now we call both Pluto and Eris and some other objects dwarf planets. One of the things that we can see in this picture is that if we look at the outer planets, Jupiter, Saturn, Uranus, and Neptune, they all have very circular orbits. Pluto actually crosses into Uranus's orbit, so at times it's closer to the sun than Neptune. Pluto is closer than the sun to Neptune for a small part of its orbit. Eris also gets very close to Neptune's orbit, and neither of these are in the same plane as the other planets, as the giant planets here. Also, both of these dwarf planets are in a region called the Kuiper Belt, and both of these are much smaller than not only these planets, but many of the large moons of the solar system. About at least 7 of the large moons of the solar system are more massive than any dwarf planet.